Titrimetric Analysis. Under this topic, we are going to discuss about the different types of titrations. There are 4 types of titrations: acid-base titrations, redox titrations, precipitation titrations, and complexometric titrations. But here we are going to discuss about only the acid-base titrations and redox titrations. Let's move on to the acid-base titrations. We can introduce the acid-base titrations as neutralization titrations. Acid-base titrations. There are 4 types of acid-base titrations: strong acid strong base titrations, strong acid weak base titrations, weak acid strong base titrations, and weak acid weak base titrations. Here you can see what are the apparatus we have to use to do this experiment to find out the endpoint of the acid-base titrations. Here you can see this is the burette, and here you can see this is the titration flask. So we have to fill the burette with sulfuric acid, and we have to fill the titration flask with sodium hydroxide. Here you have to know that we are using the sulfuric acid as the strong acid and the sodium hydroxide as strong base. We are going to do the reactions between sulfuric acid and sodium hydroxide. Okay, let's see what will happen when we are doing this experiment. We have to add the sulfuric acid drop by drop to the sodium hydroxide. The titration flask consists of sodium hydroxide, and then you can see the color change here. That means the color changes from colorless to pink color. Here you can see what will happen when we are using the indicator. Here this is the indicator we are adding. We are adding 1 drop of phenolphthalein to the sodium hydroxide flask, and then let's see what will happen when we are carrying out the titration. So here you can see when we are adding the phenolphthalein indicator, and then after we can carry out the titration, and easily here you can understand the color change from this diagram. The color change is from colorless to pink color. Let's move on to the redox titrations. Redox titrations. In a redox titration, one compound gives electrons to the other. That means one compound losing its electrons and it is said to be oxidized, and the other compound gaining electrons and it is said to be reduced. There are 5 main types of redox titrations: iodometry, bromometry, serimetry, permanganometry, and dichrometry. Here you can see the experiment for the redox titration. For this titration, you can see I use the potassium permanganate and hydrogen peroxide. This is the burette, and the burette filled with potassium permanganate, and here you can see hydrogen peroxide plus sulfuric acid. That means we are using sulfuric acid in this experiment as the facilitator for this reaction between potassium permanganate and hydrogen peroxide. If we are carrying out this titration in the laboratories, definitely we are use the titration flask for that. Okay, so I gave you this animation to find only the color change. Let's see what will happen when we are adding the potassium permanganate dropwise. You can see here. Yes, at one time, then you can see the color change. The color change is from colorless to pale pink. Redox reaction. As I told you, the redox reaction consists with 2 parts. That means one compound is getting oxidizing and the other one reducing. So this is the reducing compound of this redox reaction. reducing compound is MnO4-, it's reducing as Mn2+. This is the reducing reaction. And H2O2, it's oxidizing as O2, and this is the oxidizing reaction. And here you can see the total redox reaction of this experiment. Thank you.